Good to go, okay? So what we have is calculate the value of the letter representing the angle of each of the following diagrams, okay? So what are we guaranteed about the angle A? It's 90 degrees. Why is it 90 degrees?
3 points of triangle, 1 inside the x
and 1's the other diameter. So we're going to get 90 plus 70 is 160, then the other one has to be, because it has to add up to 180. Everybody cool with that? Once again, this one here, D, it's in a straight angle. So what you say it was? 125? Okay, that's easy enough. We know that's 90, and then that one in turn will be, has to be added up to 90, so it'll be 35. Okay, we're in business there, that's no bother. So that's 1 and 2 done. We'll have a look at the 5 and 6 now. Okay, in 5 and 6, what we're looking to do is we're looking to look for the isosceles triangle and equilateral triangles in the diagram. That's a hint. So what can I say about that length and that length? Huh? Radii. So that's 30 each. Makes this one here 120. And then there's a straight angle. And what does that do to this one here? 60. And on this one here, that's an interesting one, alright. I have to find the value of x and y. Okay, that's going to be difficult. That's x. That's x. Oh, you're right. Paddy spotted that x is an equilateral triangle. How did you spot that, Paddy? See, that's a radius, isn't it? That's the same as that length. That one isn't a radius, that's a chord. But automatically it's the same as the other one. So it's 60, 60, 60 regards the angles there. That makes this one 120. And then you know that this one's an isosceles triangle as well. That'll make that 30 and 30 because it has to add up to 180. Everybody alright with that? Okay, good. So 1, 2, 5, 6. Moving on, okay? 1, 2, 5, and 6. And now we're going to try 8 and 9. In questions 7 to 9, TP and TQ are tangents. Can anyone in the class tell me what exactly a tangent is?
When a line intersects a circle.
Sorry?
It's when a line intersects a circle.
When a line touches a circle at, let's say, 1 point only. Okay? And what's guaranteed about where it actually hits it? So it hits it here. What's also guaranteed about that? If you were to draw the radius from this point to this point, what's guaranteed about that angle? 90 degrees, or they're perpendicular, most definitely. Is that okay? So we're then going to use this information we just learned, and we're going to apply it to questions 8 and 9. And we'll do a big old diagram here. Now, in question 8, what can I say about this one here? That is 90. That one there is 90. Now, here's the interesting one. What do all four-sided objects, what do their angles have to add up to?
360.
360. So what I'm telling you guys is that 90 plus 3x plus another 90 plus x is 360. 4x plus 180 has got to be 360. 4x therefore must equal 180. X will equal 45. Is that okay?
Yeah.
Now, okay.
They look completely different sides.
Yeah, I get what you're saying, you do, but yeah, I just started it when I dragged it down that time. Okay. Lads, a question for this one here. This question here now. That 4x is relating to.
Both inside and outside the circle.
Sorry?
It's relating to both inside and outside the circle.
Oh, inside and outside the circle. I'm actually. Is that this is an isosceles triangle. That turns that into 4x. 4x plus x is? It's three angles, isn't it? So what's that? 180, which x will be equal to 20.
How come like the circle doesn't matter in this one?
Just because I had a triangle, see, I'm told they're tangents. So T to P and T to Q are tangents, and I looked up that theorem where the tangents intersect outside the circle,
Okay.
and when you draw that distance back towards the tangent points, that's guaranteed to be in the isosceles triangle. So I didn't need the circle this time.
Okay.
I couldn't have done it with the circle.
Yeah.
There's no moves there. Like, the only thing I can say is that's 90 degrees from. Like, I'd have to draw that up there and then say that's 90 degrees. That's all I can say. It's not much use to me. So 1, 2, 5, 6, 8, and 9. Okay. 1, 2. Okay, this one here. Oh yes, these ones. Okay. Okay. Something I need to explain to you in class now. Ready for this? Okay. Two terms I want to run by you. Okay. First term is this. When you have a circle, and you have the centre of the circle here, yeah? Now, can anybody tell me what's a chord? A chord is any 2 points that are on the circle drawn together, right? So I have A and B, yeah? Now, what I can do next is I can pick a third point on the circle. It doesn't matter what it is. If it's up here, I call that C, yeah? Now, see the way I end at A to B? See the way that goes from A to B? Would you agree with that?
Yeah.
Okay? That is guaranteed to be the same size as this one here. It doesn't matter where I put it. What I can tell you is it's guaranteed to be the same size. Look at the angle ADB. Is it the same size as ACB? It looks very similar anyway, doesn't it? I'm going to take a more extreme approach on this. Imagine we move D all the way over here. Actually, even a bit further. I'm going to really drag it down. Do you still think it's going to be the same size?
Yeah.
We'll find out. It's still the same size. Okay? Now, what I'm trying to... This is what's called an angle standing on a arc. So let me take you back for 1 second. An arc... The arc is this part here. That's the arc AB. Would you agree with that? The angle is standing on this arc. See the way the angle joins the arc together? That's referred to as an angle standing on an arc AB. Any other arc or any other angle that stands on the same arc, regardless of where it is, will also have the same angular value. So if I say that's 30, this one here will be 30 as well. Is that okay? Good at that? Now, the next rule I refer to is the, I call it the Star Trek sign, right? Because it looks like the Star Trek badge from the movie, okay? So the Star Trek sign is something like this. You have the centre of your circle, okay? And it looks something like this. It doesn't matter what way you draw it. You just pick 3 points on your diagram, okay? And you do it like this. 1, 2, 3, 4. Does everybody see where I'm getting that from? Okay, nerds. Now, what happens next, guys, is see the angle on the bottom. The angle on the bottom is always twice the angle on top. So if this is 50, what's the other angle down here? 100. Okay, and vice versa. If I said that's 140, what does that make that angle on top? 70. Okay. If I drew another arc right now, the dotted one, can anybody tell me the size of the dotted arc? Why? Standing on the same arc. You okay with that? Okay. Now, with that in mind, we're back to question 11. Okay? Now, in question 11, do you see any of the rules I was talking about earlier?
Star Trek sign.
You see the Star Trek sign straight away. So what are we looking to find? OBC. What's OBC, guys? Guys, OBC. What's OBC? So angle at O to B to C. This one here. Why is it 60? It's equilateral triangle. 60, 60, 60. Okay. Now, 60. Reason is it's an equilateral triangle. Calculate the angle ABC. ABC, anybody? A to B to C.
Where is it?
C, oh sorry, 75.
See, it's 15 in here, which will make that 75. Prove that BOC is double BAC.
So I just don't get why that's 75.
Because it tells me it's 15. And we calculate that as an equilateral triangle, that's 60.
Okay, yeah.
So we just added them together. Now guys, please pay attention to this one. This one is an easy enough one, but there's always this one little construction on it. When you're doing the Star Trek one, you go up the middle like that. And what you've ended up doing there is you've actually ended up doing and I'll actually make this a lot larger. Need a lot more space on that one. Okay, so this diagram here, it's the last one, so it'll eclipse the other ones. There we go. And I'm just going to enlarge it to like a reasonably large amount there. Right now, look at that there. Now, here's what I want to show you. This part here is 15. Is everybody happy enough with that? It's a radius, yeah? Same length as that one there. That makes that one 15, yeah? Now, which in turn makes 150. Happy enough with that? Okay. Same deal. Is it the same deal with the other one?
Just say that A, B, A, C. Yeah, the two sides are 75, which is 150.
Oh, because it's such a triangle, yeah. 15 there.
And 60 was 75.
Oh, yeah. Sorry guys, yeah, let's go on the junior cert proof one. Well, I think what you guys are telling me is, why don't you just take the triangle? That is 75, that is 75, that makes that one 30, and you already know that that one is 60 twice. That's much easier than what I was going to do. Well done. Okay. Now, moving on guys. Sam, wake up. Okay. So, a circle of centre O has a chord of length 30. Now what's the chord being, guys? A to B is 30. I want you to introduce you to another one. Yeah, another one, okay? So, what happens here is, anytime you have a chord, yeah? Any chord whatsoever, if you join that chord back to the centre of the, if you join that chord to the centre of the circle, if you find the midpoint, it is an isosceles triangular, right? If you find the midpoint of AB, ever see the midpoint of AB?
Yeah.
If you find the midpoint of AB and then draw a line perpendicular to AB, it automatically goes through the centre of the circle. Do you want me to go over that one more time?
Yes, please.
One more time, okay? So, what I said is, if you draw a chord, A to B, draw a chord A to B, like so. If you get the midpoint, are you ready for this? If you get the midpoint of AB, then you draw a line that goes through the midpoint of AB, but is perpendicular to AB, it's guaranteed to go through the centre of the circle. No matter what way or what angle you draw that circle, it's going to be always doing the same thing. It's always going through that middle part. Okay? Next thing is, you can then expand it into two right angles. triangles, use Pythagoras' theorem and work with it that way. So let me explain how I'm going to do this question here. So, okay, what you have is, you know that this is 30, that makes that one 15 and that one 15. I know that O to M is 8. It then wants me to find A to M is 15. It's the midpoint, so hence half of it. Calculate the length of the radius. How do you calculate the length of the radius now? Any takers, guys? Why don't you try Pythagoras' theorem? Yes. Now, x squared equals 8 squared plus 15 squared. X squared equals 289. X equals 17. Okay, it's off length 17. Okay, calculate the area of the triangle OAB. What's the area of a triangle again?
Half base times height.
Half base times height. Do we have the perpendicular height? We do, because it's O to M. What's the base, guys? The base is 30. What's the height?
8.
8. So we can do a half. 8 times 30.
Half 30 times 8 is
120. Okay, that's 120. Now, I think we should leave that for. I think you've had enough information for one day.